Hello my genius students. Today we are in lecture number 41. It is lecture 41 of third chapter, current electricity segment. Okay, student, today's lecture is important because you will do here the two questions of one 5 marks and another of 3 marks. Okay, this is the very important for the board examination. The first we will study in today's lecture the balance Wheatstone bridge. Okay, the balance Wheatstone bridge. And this particular balance Wheatstone bridge will be work as a principle for the next topic that we'll study, the slide wire bridge, that is the Metre bridge. Okay, so the balance Wheatstone bridge, the very important, the balance Wheatstone bridge, student, remember this balance Wheatstone bridge, nothing a very difficult thing, but it is a special designed circuit, okay, or the network. It is the special designed circuit or the network, circuit or network of electronics. Okay, the name Wheatstone. Wheatstone actually use the 4 arm resistors. Okay, let me draw the picture. The particular Wheatstone bridge we have studied also while solving the question of capacitor. I told you that we'll study in detail in this chapter. So as per my promise, I'm starting this one. Here we are using a galvanometer. I hope you understand, my dear students. If you go in your school library, you will find a galvanometer in library. Actually, this galvanometer used to measure the current, used to detect the flow of current in any circuit. It used to find the continuity. Remember, this galvanometer can be also converted in different instrument like voltmeter, ammeter. Here the 2 point, I'm writing the A and B. Now these are the 4 arm resistors of this Wheatstone bridge. Here you can apply a battery of voltage V. The 4 resistor, I'm giving the name. It is the P ohm, Q ohm, R ohm and S ohm. Now you don't have to study in detail about this balanced Wheatstone bridge. You know very well that we have another unbalanced Wheatstone bridge also that we used to crack with KVL or KCL. Here we are going to study about the balanced Wheatstone bridge. Now, regarding this balanced Wheatstone bridge, we are having the condition. What is the condition? If this bridge is balanced, then we are having a condition. Remember, if this is balanced, if it is not balanced, then this condition will not satisfy. If this condition is satisfied by the circuit, then this circuit will be considered the balanced Wheatstone bridge. Okay, and the structure of balanced Wheatstone bridge, you know very well. The different types of balanced Wheatstone bridge have been drawn in capacitive circuits. So the condition, if P by Q is equals to R by S, or P by R is equals to Q by S, then this is the condition, remember, then there will be no current flow through the galvanometer. Then IZ will be 0. Very, very interesting. Then IZ will be 0. That is, galvanometer will not show any deflection, and this galvanometer is said to be in null deflection state. If no current flow from this galvanometer, it means potential of A and B is equal. Of course, that's why the current is 0. So you can write also the VA is equals to VB, and this is the entire condition of balanced Wheatstone bridge. Even you may ask in board examination to satisfy this condition. That is, you have to prove the condition, yes, using any one condition, either this one or this one. If you are using IZ equals to 0, then you have to prove P by Q equals to R by S. If you are using P by Q is equals to R by S, then you have to prove IZ will be 0. So you can prove this one also. Okay. So we are going to prove this particular condition. Are you ready, my student? Okay. So proving. For proving, we'll use Kirchhoff's law. Kirchhoff's law. Let's start the distribution of current. And the current is going I from the battery. The current is breaks in two, that is I1 and I2. I hope this is visible to you. Here the current is IZ, that is the current across galvanometer. What current will reach over here? Same IZ. Now look at here carefully. This I2 is coming and this IZ is coming from here. So the current at this resistor will be how much? It is IZ plus I2. I hope you are agree with me. It is I2. Now here the current I1 is going, IZ move across this section. So what will be the current over here? It will be I1 minus IG. Okay. Remember students, you don't have to say, sir, if this current is 0, then why we are using here the IZ? My dear student, actually we are going to prove IG will be 0. We don't have to suppose, yes, it is 0. Then how will prove? That we have to suppose that, okay, it is IZ. Then after we will prove, all right, this IZ is 0. Okay. Now write this terminal as the X and Y. In loop XABX will apply KVL. Okay, will apply KVL. So you can write the PI1, P times I1. Now in the direction of current we are going. The resistance of galvanometer, suppose it is Z. G is the resistance of galvanometer. What? Z is the resistance of galvanometer. Okay. So here the resistance, so the current voltage will be IZ times G plus IG into Z. Why? We are going with the direction of current. Now we have to move across this one and it will be minus how much? I2R. I2R is equals to 0. We start moving from this point and reach to this point. Okay. You can also simplify this one, or you don't need to we simplify the second. In loop, which one? AYBA. Okay. Write down the equation. So we can write here I1 minus IZ times how much? Q with the current we are moving minus, all right, minus SIZ plus I2 again minus IZ times Z equals to how much? It is 0. The equation 2. All right. Now what we have to use? We have to use any one condition, that is IZ equals to 0, and we have to prove this one. Okay. So I'm writing since IZ is 0. Now my dear students, you can prove by yourself. Put IZ 0 in both the equation 1 and 2. Okay. Put down and then you will divide these two equations. You will find this is satisfied. All right. Okay. Try to prove by yourself. This equation 1 becomes, if it is 0, okay, I hope you have noted down. Directly I can prove over here also. If it is 0, let me wrap this one. If it is 0, then this will gone. If it is 0, then this will gone. If it is 0, then this will go. Now you can see this also. You can see P I1 is equals to I2R. from here P I1. Remember, you will write in the next steps. Don't erase in my way. P I1 is equals to I2 R, that is I1 by I2 you can write as R by P. Okay, I1 by I2 R by P. And now from here I1Q is equals to I2S because it is 0. I2S, again I1 by I2, I1 by I2, I1 by I2, what you will get? S by Q, S by Q. Okay, so this one and this one relation you will equate, left hand side same. So R by P is equals to S by Q. R by P is equals to S by, it is S by Q. Okay, S by Q equals to R by P. Or you can arrange to see this particular equation as P over here. So the P by Q and this S will be down, R by S. Now you can see we have to prove. So we have proved, yes, this is the condition of balanced Wheatstone bridge, my dear student. Okay, let me see a few questions which is based on the balanced Wheatstone bridge that are very simple. I hope that you can solve that question before I'll start solving. All right, so the first question. First, you will find whether it really realizes this is the balanced Wheatstone bridge, and then you will start solving the question. Whenever you find such type of question, you don't start with the yes, it is balanced Wheatstone bridge, and then you will find, oh my god, it is not the balanced Wheatstone bridge, and you got 0 over your answer sheet. So first you must apply your IQ to find whether this one is balanced Wheatstone bridge or not. All right, so all the resistors are 2, 4, 4, 8, 2, 2, 12 volt. Okay, kindly tell me whether this one is balanced Wheatstone bridge or not. So the answer is 2 by 4 and 4 by 8. It is 1 by 2, 1 by 2. Yes, sir. It is balanced Wheatstone bridge. If it is balanced Wheatstone bridge, so the no current will flow and this will be considered the open circuit. So you can remove this one from the circuit. Now you can see this is very easy. 2 and 4, 6 ohm. Down this resistor. 4 and 8, 12. It is connected with another resistor and a battery of 12 volt. Alright, so 12 and 6. It is R equivalent, that is the total. Not the total, but this one, it will be, I'm solving this one as R 12 6 are 72 and 12 6 18. So it is 4 ohm R. So the total resistance R equivalent, what else? This is 4 and this is 2. So the 6 ohm. If you will be asked to find the current across each resistor, the total current, whatever you will ask, you can solve such type of question. Okay. Now the next question. First, you will tell me whether this one is balanced Wheatstone bridge or not, and are you able to solve such type of question or not. Okay, this is the battery of voltage V. Alright, R This is all connected with the resistance R, all the resistance R, okay. And this is the battery V. You have to find the equivalent resistance of this network, okay. Find equivalent resistance of this network. Could you solve? If you can solve, then find out. All right, now let me tell you, student, try to see this particular structure. I have helped you in capacitor also. Try to see this particular structure in this way, okay. Just remove this battery, pull this resistor a little bit down, okay, and this one also, because this is the flexible, you can make it enlarge, pull down, okay, and then this will also go down. This is the resistor. You can see this is point O, and this O comes at this point, okay. You're pulling this one, but a resistor is connected in between these two, and a battery was also connected here, na? A battery was connected, so we are connecting here the battery, this one. All right, now you can see it is R by R, same, so this will be erased. Now the 2R, it becomes R, and here the R is connected, so R by 2, the equivalent resistance. I hope you understand, okay, my dear student. Now the next one, the one very important question I made today for you, I'm giving you for this balanced Wheatstone bridge. I think 4 to 5 questions I have added in assignment, so you can solve in my both the assignments. All right, so the question, this is a very important question, and this is your homework. All right, yes, this is your homework. And the question is, a wire of length 6 meter. You are having a wire of 6 meter, and the total resistance of this wire is 60 ohm. All right, yes, wire having length 6 meter, and the total resistance of the wire, it is 60 meter. Now this wire is divided in 2 pieces, okay, A and B, in 2 sections, A and B, as A is to B is 4:2, okay. The 2 sections are divided in 2 parts in 4:2 ratio, okay. Now A part form a circle, all right, and part B form 2 diameters like this one. We divide this B to make 2 wire, and it forms 2 diameter. I hope it is very clear. You have to find R equivalent will be what? Across any 2 end of any dia. Suppose if you are taking this 2 dia as X and Y, then you have to find the R equivalent across this 2 dia. What will be the R equivalent? This is the complete question. I explained. I hope I am clear. And now, my dear students, we'll move for the next very important topic. It is called meter bridge. Okay, it is called meter bridge. Let me erase this one. Can you note down the question? Now, meter bridge. Okay, my dear students, we are going to start meter. Remember, my dear students, this meter bridge is the portion of your experiment also. and you have to take this experiment very seriously. In fact, all the experiment of 12th board very seriously, because 30 marks you will get from the practical exam. Okay, and this is one of the very important question of experiment as well. The meter bridge, this is also called the slide wire bridge. Slide wire bridge. Why actually this is called meter bridge? Because the length of meter bridge is found to be 1 meter. We used to made a meter bridge of 1 meter. That's why. Okay, we'll see what is the structure of meter bridge. Actually, this meter bridge has two uses, the very important use. One is to divide the resistance or the potential, and second, to find the resistance of unknown conductor, that is the unknown wire. You can find the unknown resistance using this meter bridge. Here we will study what is the principle behind this meter bridge and on what two method is work. But first we'll draw here the diagram. Okay, this is also known as the circuit diagram of meter bridge. Let me stop the video, and finally you will see a meter bridge. Let me draw before you so that you will learn to draw it. My dear students, it is made up over a wooden board that is non-conducting. These are connected, well connected with the metal strip. These are well connected with the metal strip. The 3 points over here. All right. 1 point over here, 1 point over here, one here, and it is calibrated with a scale. The 0 centimeter start from here, tick 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 tick. Here, that is I'm giving the calibration. It is made up with the scale. A scale will be this over here. All right. Okay, my dear student. Now, a wire of uniform cross section and the same material, it is provided over this meter bridge, and this is the main component. Okay, this is the wire. Now we will connect here a known resistance. Usually we find a known resistance from resistance box, say R. We'll connect here unknown resistance. We don't know the value that we have to find. Let it is X. Okay. We need to connect a current source. So in lab, we will connect it with a battery eliminator that can change the potential also. Remember students, you can use here the rheostat also. A very simple diagram I am giving you. The voltage V, and this terminal you can see only this one is left. This is connected with a galvanometer, and this galvanometer gives you the value of current, whether current is flowing or not. It is connected with a jockey here, metallic jockey. What does it mean, this jockey? Jockey is a metallic pin like this one, and this will be the metallic. Inside this pin there will be metallic connection, and here you will find the terminals with which you can connect the wire, this wire, and which goes to the galvanometer. Okay, this one, this is galvanometer. My dear students, this galvanometer shows the deflection, whether current is flowing across here or not. This point is termed as where this galvanometer will give you the zero current, this point is called null point. Okay, N. If this is the length L from A to this null point, then what will be the rest length? It will be 100 minus L. Alright, if it is length L, this L is called balance length. And this 100 minus L is called rest length. This N is called null point. Null point. In examination, if you find this question, then you can write by giving the lessons. This J is jockey, Z the galvanometer. Okay, this is the battery eliminator. This is the known resistance. This is unknown resistance. You can write in your notes properly. All right. Now, if this is the length L and this is the length having the same material, what will be the resistance? You can write resistance is directly proportional to the length. All right. So here R is 5 times L. Suppose the resistance, here I am writing resistance, not this R. Okay, let me write R dash. So resistance of this L length, let me write here the RL or R dash. Resistance of this L length will be R dash, and the resistance of this one, if it is R dash, so the resistance of this one R double dash, you can write as 5 times how much? 100 minus L. Very simple. Now you can see this can be arranged in such a way it looks like Wheatstone bridge. Remember, my dear student, how you have to note down in your note copy. First you have to write the meter bridge, then you have to write the circuit diagram, and you have to draw this one, and then you have to write the principle. Remember, principle. Okay, so the principle will be, it works, kindly write down in your note copy. It works on principle of balanced Wheatstone bridge. Okay, after principle you have to write the method. Okay, so write down in method, it works on null deflection method. Okay, and then you have to write the theory of this meter bridge, and you will include this in theory. Okay, now my dear students, this circuit diagram you can arrange in this way also. You can see this is the point and this is the point. In between these 2 points we are having galvanometer, this point and this null point. Okay, this is null point. This is the resistance R, this is the resistance X, and this is the resistance R dash, and this is the resistance R double dash, and we are having a battery also. Now, if current at null point, what does it mean? IZ is 0. Remember how you have to perform this experiment. This all are errands. Okay, after giving the switch on, you have to put this jockey at one end. As you will put this jockey at one end, what you will find? You will find the large deflection in galvanometer. One side, remember, one side. When you will put this jockey from here to at this point, you will find the deflection in galvanometer to other side. Remember, what does it mean? If from here to here, if the pointer of jockey go to the another maximum end, it means at somewhere this galvanometer reached to the null point also. Now, what is the null point actually? You haven't studied about the galvanometer. Remember, this is the galvanometer. Look at here. If this is the galvanometer, in galvanometer points are, the readings are given in this way. This is 0, then 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4 in this way. And this is the pointer. right now this pointer at 0. This pointer moves when current flow to this side, and this pointer move when current flow to this side. Remember, this pointer don't start from here. This pointer remain at 0 if current is 0, then at this point. Now again, focus over here. If you keep the jockey at point A, you find the pointer move to the maximum. As you put the jockey at point this one B, you find the jockey but the galvanometer move to the maximum over here. It means there is a point at which this galvanometer will be at how much? At 0. And at that point you can say the current from this particular wire is how much? It is 0. And that point is called null point. Alright. So I'm rubbing this one. This was the simple structure of galvanometer. I hope you understand. Now, my dear student, as the current will be 0, what will happen? You can find if it removes, these two are in series, or if this galvanometer gives 0 current, if this current 0 Ig is 0, then what will happen? This R by X is equals to R dash by R double dash. Okay. Now your problem solved. You have to find the unknown resistance X. So you can write, let me erase this one. So you can write as unknown resistance is X. So the X is equals to R times R double dash divided by R dash. Okay. And it is nothing but the R double dash was how much? It is 100 minus 5 times 100 minus L divided by R dash, it was 5 times L. Okay, so it is R times 100 by L minus 1. You can see 5 will be cancelled out, and this is the value of unknown resistance. I hope my dear students, you understand this particular how to find the unknown resistance. I don't think this is the very tough. There's a one numerical question, my dear student, you can solve. It is given in your NCERT. And the next question, my students, we will discuss in next lecture. We will start the next lecture with the numerical of this meter bridge. Okay, my dear students. But remember one thing, I'm telling you again, after this lecture, you must find out on YouTube the experiment of meter bridge. Okay, and try to see that experiment. After studying this one, you will be able to understand that experiment, and it will be very easy when you will go to the lab, experiment lab, then you can understand very well. Okay, my dear students. So this is all about the today lecture. Thank you very much.